This new section is entitled Slopes. The slope of a line is a number. It talks about how steep the slope is, or how steep the line is. For example, if that's the horizontal, say maybe it's level ground. This slope is not very steep, but this slope is steeper. And that slope, is steepest of all the other three. This one is even steeper. For example, if you don't like walking up a hill, for some reason, M stands for slope. Now, if you don't like walking up a hill, but you have to walk up a hill, I suspect that you would like to walk up this hill. Why? Because it's not as steep as number 2. It's not as steep as the third line. And the fourth one, I don't think anyone would like to walk up. It's very steep. Okay. Now, in each of those slopes that I just drew, as you go to the right, the line's above. The very steep one, pick a point on the curve, go to the right. The graph goes up. Every one of them. Pick a point on the line, can be the middle. When you go to the right, the graph goes up. Those are positive slopes. All those lines have positive slopes. Except the very first one. We'll talk about that in a moment. Those slopes are all positive. Again, pick a point on the line, go to the right, and the line is above you. That's a positive slope. Negative slopes, they have the same steepness, except we call them negative. Right? So again, make believe this is level ground. You have this line, has their slope that corresponds to it. That line has a slope, a number. Remember, a slope is a number. It has a slope that corresponds to how steep the line is. This line, of all the ones I drew, is steepest. Okay, let's get rid of the bottom one. Now, it turns out on these lines, if you pick a point on the line, when you go to the right, the line's below you. If you pick a point on the line and you go to the right, the line's below you. If you pick a point on the line and you go to the right, the line's not above you, but there it is, right below you. If you go to the right and then you have to go down to hit the line, you will have a negative slope. You have a line with a negative slope. Okay. Our slope is a number, and it talks about how steep the line is. The steeper the slope, the bigger the number. Maybe this slope would be your half. This slope's a little steeper, maybe it's 1. But they grow rapidly. Maybe this is 100. And this slope, the top one, is 250. Excuse me. Okay, that last slope, 250. The other slopes, they're defined by the same steepness. Like maybe this line and this line, they look to be just as steep. But that one's negative. Slope 2 looks to me like negative 200. And slope 3, negative 500. There's the slope is a number. Can be the square root of 7, any real number. Now, if you have just a horizontal line, the slope is 0. Now, I want to So horizontal lines, they have no slope. There's no steepness associated with them. A horizontal line, it's level. All right. Now, let's put this little vertical line here. This line has a positive slope. Again, I go to the right, it goes up. Maybe the slope is a third. And this line, it has a bigger slope. Maybe it's 1. And this line, maybe the slope is 10. And this line, maybe the slope is 500. And that line, maybe the slope is 10,000. This line, maybe the slope is 400,000. They grow quickly. Okay. This slope is not very steep, but it's negative, because if I pick a point on the line and I go to the right, the line's below me. This slope is maybe negative a half. This slope, the slope of that line is negative 1. And then negative 500. And then negative 100,000. Well, notice I kept making the lines or the slopes closer and closer, or approaching the vertical line. Even in the other direction. I only went that much, then I went more, then I went more, and then I went further. I keep getting closer and closer to the vertical line. Well, as I go closer this way, I get more and more negative. As I go closer this way, I get more and more positive. They're not approaching any finite number. In fact, they're not even approaching infinity. When you go this way, these lines, the slopes are approaching negative infinity. The other positive infinity. When I'm going this way towards the vertical line, the lines are approaching negative infinity. A vertical line, the slope is undefined. The slope is undefined. Remember, M stands for slope. Horizontal lines, the slope is 0. Positive slopes go that way. Negative slopes, M is less than 0, that means negative. Negative slopes go that way. Again, as you go to the right, expect the graph to be beneath you for negative slopes. As you go to the right, the line's above you. As you go to the right, the line's above you. That's the positive slope. So, vertical is undefined. Horizontal, the slope is 0. Positive slopes, negative slopes. Talk more about parallel lines. That's the symbol for parallel lines. Parallel lines. Okay. Parallel lines have the same slope. Actually, say it perfectly. Two non-vertical parallel lines have the same slopes. Why am I removing the vertical lines by saying non-vertical? Because those two lines, they are parallel, but they do not have the same slope. This slope is undefined. The slope of this line is undefined. Undefined does not equal undefined. Okay, that's the way it is. It's undefined. How can it equal anything? How can you say, I'm thinking of a number, two students say, I'm thinking of a number, but it doesn't exist. Student 1 says, I'm thinking of a number, but it doesn't exist. Another student says, I'm thinking of a number also. And you know what? You won't believe it, but the number doesn't exist. There's no reason to assume they're thinking about the same number. Okay, undefined does not equal undefined. So, when are lines parallel? Well, for non-vertical lines, if they have the same slope. Okay, and I will say that vertical lines are parallel. Okay, so I say two parallel lines have the same slopes, and I'll say it, let's say it in if-then format. If you have two non-vertical lines, non-vertical parallel lines, then they have the same slope. Then they have the same slopes. Now, I can say it in reverse. I can say if two lines have the same slopes, then they are parallel. If two lines have the same slopes, then they are parallel lines. They go both ways. If these two lines have the same slope, then they're parallel. If these two lines are parallel, then they have the same slopes. Vertical lines are parallel if two lines do not have a slope. That is, their slopes are undefined. If two lines do not have a slope, then the two lines are parallel. They come hand in hand. Okay. Just talked about parallel lines. Now we're going to talk about perpendicular lines. Two lines are perpendicular, and this is for the case where no horizontal line. You have two lines, none of them are horizontal. Two lines are perpendicular if their slopes multiply out to -1. If one line has a slope of 0, that is, it's horizontal, that is, horizontal line and the other line does not have a slope, does not have a slope, that is, it's a vertical line, that is, it's a vertical line, then the lines are perpendicular. Then their two lines are, and maybe I didn't say it at the very top, but that last symbol that I wrote on the bottom and the symbol I wrote on the top mean perpendicular. Sorry about that. Perpendicular. Now, what is perpendicular? You have one line, and you have another line. And they meet at a right angle. Those are perpendicular lines. If you have this line, and, that line, they meet at a right angle, they're perpendicular. If you have this line and that line, they meet at a right angle, they're perpendicular. And if one is horizontal and the other one is vertical, they're also perpendicular. Now, if this slope, which is positive, is a half, then the other slope is basically flip that over. 2 over 1 is 2, and change the sign. These two numbers multiply out to negative 1. If this slope is, for argument's sake, 3, or 3 over 4, then the slope of this line, well, you flip it over. If you multiply two numbers that are reciprocals of one another, you get 1. If you want negative 1, change the sign. If you flip over 1 and change the sign, you'll have the other slope. This slope maybe is negative 7 over 2. So this slope will be, flip this over, 2 over 7, and change the sign. The sign is negative, that number should be positive. You don't have to write the slope. Now, why did I have to isolate this one? By talking about horizontal and vertical. When over here, I just said the product of the slopes multiply out to negative 1. Well, it's a very simple reason. Here, m is 0. And here, m is undefined. Well, when you multiply those two numbers, you don't get negative 1. You don't get negative 1. You don't get anything. How can you multiply 0 by a number that isn't even defined? For the record, you don't get 0. It is not true that 0 times anything is 0. If your teachers have told you that, well, either they don't know or they don't think it's the appropriate time to tell you. That's not true. 0 times undefined is not 0. For example, 7 over 0 is undefined. When you multiply it by 0, you still get undefined. You get undefined. You don't get back 0. Alright. So now, we talked about at the beginning how the slope of a line has a number. It talks about how steep it is. Why is the slope of that 2? Why 2? Well, the formula to calculate the slope is the change in y over the change in x. That triangle means change in. The change in y, the change in the y values, divided by the change in the x values. Okay. Basically, if you have a line and you have any 2 points on it, 2, 7, 4, 11, what is the slope going to be? Well, the change in y went from 7 to 11. Oh, it went up 4. How do you like that? The change in x went from 2 to 4. It went up 2. So I could have used the line above, because coincidentally I got that slope. Now, if for whatever reason you don't want to go from the lower point to the higher point, that's fine. You can go from any point to any other point. You can go from 11 to 7. And that's a change in y. It went down 4. And x goes from 4 to 2. It went down 2. But we still get the same answer. We still get the same answer. For example, if this point 615 will also be on this line. It will also be on this line. It will also be on the line. Trust me on that. Well, you can use any points, any 2 points on a line to find their slope. For example, if y goes from 15 to 7, it went down 8. And if x goes from 6 to 2, if x goes from 6 to 2, it went down 4. Negative over negative, just like up there is positive, and 8 over 4 is 2. Any 2 points on the line, any 2 different points on the line will give you the slope. Doesn't matter which 2 points you use. Any 2 points on a line will give you the slope of the line. Any 2 points will give you the slopes of the line. Let's try another one. If you come to know that on this line you have 2, 5, and, well, that makes no sense, and 4, negative 6. What is the slope of this line? Well, like any line, it's a change in y with a change in x. And how you go from one y to the other is up to you. That is, you can go from the top one to the bottom one, or you can go from the bottom one up to the top. If you go from 5 to negative 6, you went down 11. If you're on the 5th floor and you go 6 floors below the basement, you went down 11 floors. I know you did, because from 5 to 0 is 5, and then from 0 to negative 6 is 6. You went 11. You went down 11. You can do that. And now, x goes from 2 to 4. That went up 2. There's your slope. Reduce it if you can. That is the slope of that line. Okay. Now, I could ask you as well, what is the slope of a perpendicular line to the given one, to the one on the board right now? What would be the slope of a line that was perpendicular to this line? Now, I'm just going to draw the line again. But I didn't do a good job. It doesn't look like the same slope. Here's the same line. Now, perpendicular means that way. Now so I'm asking you, well, what's the slope of that line? And you may say, but this is also perpendicular. So why don't you ask for, how come you're not asking me for the slope of that one? Because it also meets at a right angle. And even this line meets the original line at a right angle. So why don't you ask me for that slope? Well, this line and this line and that line, they're parallel to one another, which means they have the same slope. So I'm just asking for any old line. What would the slope be? Any old line that's parallel, perpendicular to the given one, like the top one. It meets at a right angle. I want to know what the slope is. And calculating the slope is straightforward. Remember that we just calculated the slope. Remember, this line and the one that I just drew are the same. If you want to see the points, there they are. 2, 5, and 4, -6. So I know the slope of the line that I just drew because we just calculated it. It's -11/2. What's the slope of the perpendicular line? Well, flip it over. Ignore the signs for now. Ignore the signs. Flip it over and change the sign. Since that number is clearly a negative number, our answer is positive. And whether you write the positive or not, that's up to you. And some people, like your teacher, might suggest that instead of writing M, you write M with a perpendicular next to it. The slope of the perpendicular line is 2/11. So let's try that again. I'll give you a line with some points on it. If I give you more than 2, pick 2. Any 2. Doesn't matter which 2 different points you pick on the line. The slope will be the same number. Okay. So suppose I give you this line and I tell you it contains -3, 4 or -4, and this line contains 5, 5. Calculate the slope of a perpendicular line. Sorry about that. Calculate the slope of a perpendicular line. For example, find the slope of that line. Meets at a right angle. So we're going to call the slope of the original line M, and of the perpendicular line M subperpendicular. So let's find the slope of the original line. Well, like every line, the slope is a change in y with a change in x. If you go from -4 to 5, you went up a lot. You didn't go up 1. Because I know if you go from 4 to 5, you've gone up 1. Stop and say hello to 0. You go up 4 and then you go up 5. If the numbers are opposite signs, one's negative and one's positive, if you do this enough, you say, you know what? Keeps happening. This guy knows what he's talking about. Just add those two numbers, the absolute values. Add the absolute values. That is, add the numbers without signs. That's 4, that's 5, you add them, you get 9. That's if they have opposite signs. Okay, so we know the change is 5, and since we went, is 9, excuse me. Since we went up, it's positive. Positive 9. We went from a negative x value, negative y value, to a positive y value. We went up. Now what's the change in x? Well, we're going from negative to positive. Oh, it too is going up. The signs are different. Just add the absolute values, 3 and 5. You go from -3 to 5. Well, first you went up 3, and then you went up 5. 3 plus 5 is 8. Positive over positive is positive. You don't have to write it. So the slope is 9/8. The slope of the perpendicular line, just flip that over. Realize, since there's no sign, that it's a positive number. And for the perpendicular one, you change it. If you're not positive, if you change a positive sign, you must have changed it to negative. Okay. Now, let's play a little game. I will give you 2 points, but not exactly 2 points. and I'll give you the slope. So let me explain to you. Here is 1 point, 2, 7. Here's another point, 3k. And I tell you that the slope is 5. And the question is, find k. Okay. So on one hand, the slope is the change in y to the change in x. Well, if x goes from 2 to 3, it went up 1. Now, how much did it go up? I know it went up. I mean, let's face it. We went up. That's the change in y. You went up that amount. And x also went up. Okay. So how do you find out from 7 how much you go to k? Simple answer. You subtract. You subtract. You know, for example, the y value here is 7. Let that be the y scale. And the y value here is k. If you want to know how far that is, if you want to know how far it is from 7 to 10, don't you compute 10 minus 7? So here, that is the top minus the bottom. And that definitely should be something that you have. Alright, dividing by 1, don't even bother. You just get the numerator. So on one hand, the slope is k minus 7. On the other hand, you were given the slope is 5. This is a puzzle. Find k. Some number, when you take away 7, gives you 5. You should know that. It's 12. 12 minus 7 is 5. So, k is equal to 12. Let's do a similar problem. Except this time, I won't give you the slope of the line. I'll give you the slope of the perpendicular line. A line goes from -2, 5 to 3k. I'll give you the slope of this line. The slope of the perpendicular line is -4. Okay. Question is to find k. Well, what is m, the slope of the original line? Well, the slope of any line is the change in y over the change in x. The change in x, well, you went up 5. Okay, you go up some, that's positive change for y, and then you went to the right. Went to the right 5. You're at -2, and then you end up at 5. How about 3? You end up at 3, you go 5. Now what's the change in y? Well, it's the top value minus the bottom value. And it is positive. It's the top minus the bottom. That is k plus 2. And this, okay, so it's k plus 2 over 5. Now, if this is the slope of m, on one hand, the slope of the perpendicular line, well, you flip it over, and you change the sign. And I say that this is -4. Well, to be honest, you should know what this is. You should know what to divide -5 by to get -4. And the answer is -5/4. Sorry, +5/4. But probably a lot of you don't know that. So we need to solve this. -5 over k plus 2 is -4. I hate my variables being in the denominators. This is the same as -4 over 1. If two quantities are equal, like 2/3 equal 2/3. If you take their reciprocals, they're still equal. Negative 2/3 equals negative 2/3. Their reciprocals are equal. That is, k plus 2 over negative 5 is equal to 1 over negative 4. And I will multiply both sides by negative 5. So I have k plus 2 is 5 over 4. 1 times negative 5 is negative 5 over negative 4. Just 5 over 4. Take away 2 on the left side, you get k. And you have to take away 2 on the right side. But it's not friendly to write 2 on the right side. It's friendlier to write 8 over 4, or negative 8 over 4. That's also negative 2. And the denominators are the same now. 5 minus 8 is negative 3. That is the value that k should be. Let's do one more silly type problem. I'll give you a triangle, give you the endpoints of the triangle, the coordinates of the endpoints, and you find the slope of each line. This 3, 4, x goes up, y goes up, x went up more, y went down just a little. So I want to know the slope of that line, the slope of that line, the slope of that line. If I also went and called these A, B, and C, find the slope of AB, find the slope of AC, and find the slope of BC. Okay. The slope of AB equals AB. Well, y goes from 4 to 6. Went up 2. X goes from 3 to 5. Oh, it also went up 2. Slope is 1. What is the slope of AC? Which is this line here. Well, x goes from 3 to 7. Went up 4. Y goes from 4 to 3. It went down 1. Negative 1/4. What is the slope of BC? Which is this line. Oh, x goes from 5 to 7. Went up 2. Y goes from 6 to 3. Went down 3. A negative over a positive is negative. Slope is negative 3 over 2. Okay, that completes the section on slopes.